All right, so today we're going to be looking at Unit 8, Notes number 4. And we're still looking at systems, but we're finished with graphing, so congrats, you made it through graphing. Now we're going to be looking at how can we solve application problems with these systems. This is actually something that we've already kind of done before, so you might feel like this is pretty familiar, and if so, awesome. Um, Also, please make sure that you're really taking your time on those Google Forms. Remember, we're grading those Google Forms based off of accuracy and completion. So you get 10 points for just completing it, but then those next 10 points come from how well you did. So if you hurry through that Google form and you only get 2 questions right, then you're probably only going to get 2 points on that in that section. So please make sure you're really taking your time on those Google Forms. All right, so looking at problem number 1. This is a problem straight out of a Harry Potter book, so if you haven't read the books, you've got some time to do that now. So I highly recommend it. So there are 60 students currently taking care of magical creatures, and the class size is decreasing at a rate of 5 students per year. There are 40 students taking potions, and the class size is increasing at a rate of 15 students per year. If this continues, in how many years will the class sizes be equal? That right there is what we're asking. How many years? So we're going to let x equal the number of years. That should be an A. Okay, so now we're going to write our equation. We're starting with care of magical creatures, which starts with 60 students, but they're decreasing. Okay, so we can see decreasing at a rate of 5 students per year, so 5x. And we're going to set that equal to the potion students, which there are 40 students taking potions. And that class size is increasing at a rate of 15 students per year, so plus 15x. Okay, so from there, we're just going to solve for x. Okay, so we're going to subtract the 40 from both sides. I'm also going to add the 5x over. So those will cancel out, and I'll have 20 is equal to 15 plus 5 gives me 20x. I'm going to divide out the 20. And I'll get x is equal to 1. But that's not my final answer, because from there, I have to then explain my answer. So I need to say it'll take 1 year for the classes to be equal. Well, maybe. There we go. All right. So now looking at our second one. So this was a problem that we did way back in like Unit 1. So now we're going to look at how can we actually set up a system to represent that type of problem. So looking at number 2, okay, it says set up a system of equations to represent the total cost for both types of donuts. Okay, so our base price for 12 donuts is $15 and $10, and then the price for each additional donut is $1.50 and $1. So we're going to first define our variables. Those additional donuts, that's going to be our x. So we're going to let x equal the number of additional donuts. And then we're adding up all of those costs to find our total cost. So we're going to let y equal the total cost. So from here, we can actually set up our system. So our first line is going to be our pink line that's glazed. So our total cost, or our y, is going to equal $10 plus that $1.50x, because it's $1.50 per additional donut. And then our second one is going to be our pink line, sprinkles. It's going to be y is equal to 15, and then plus our dollar per x, or $1 per donut. So this right here is our system, and if you look at these pieces on the right side, that kind of matches what we were doing up here, okay? And that's how we will find when they're equal. Okay, so those are basically the same thing, just represented a little bit differently. So part B says how many additional donuts do you have to buy for the cost to be equal? I want to know when those two things are going to be equal to each other. So I'm going to set those two pieces equal. Okay, so we're basically taking this 10 plus 1.5x and plugging it in for the y. Okay, we're going to plug that in for the y and set those equal to each other. So now I'll have 10 plus 1.5x is equal to 15 plus 1x. And now I can solve for x. I'm going to subtract my 1x over and subtract the 10 over. I'll get 0.5x is going to be equal to 15 minus 10 gives me 5. Divide out the 0.5, and I'll get x is equal to 10. All right, but that's not my answer, okay? My answer wasn't just x equals 10. My answer should be 10 additional donuts. It will take 10 additional donuts. All right. And so then part C says, what will the total cost be when the costs are equal? So right here, we know it takes 10 donuts, or we know that our x is 10 whenever the costs are equal. So we can take that 10 and plug it in for one of the x's. So we're just going to use this bottom one right here because I'd rather use the one without the decimal. So we're going to have y is equal to, I'm just going to rewrite the equation, 15 plus 1x. So we're going to take that 10 and plug it in for the x. So I'll have y is equal to 15 plus 1 times 10. We'll simplify that. 1 times 10 is just 10, plus the 15 will give me 25. So my y is equal to 25. Well, we don't care what y really, we didn't ask what's y equal to. We asked what's the total cost going to be when they're equal. So we're going to say $25. And you can plug that 10 into the other equation too, into that one up there, and it'll also give you 25 as well. They'll give you the same thing. That's the really cool thing about a system, is a system lets you find the x's and the y values. You're not confined just to finding one value. You can actually find both. Because when we started up here, you could only find this x. Okay, we only found the years. But now we can find both pieces, both of those important pieces. All right, let's look at our next page. So flip your page over, because hopefully you printed this out. We have another Harry Potter example, so get excited. I know I am. So number 3 says, at Hogwarts, there are 50 students currently taking Transfiguration, and the class size is decreasing at a rate of 2 students per year. There are 30 students taking Arithmancy, and the class size is increasing at a rate of 3 students per year. This probably reminds us of that first problem we did. So we're going to express the problem as a system of equations and define our variables. So now instead of using an equation, just one equation, now we're going to be using a system. So we're going to start with defining our variables. We're going to let x equal, just like in the last problem, it's going to be the number of years. And we're going to let y equal the total students, because we're looking for how many kids are in each class. So now we're going to set up our system. We're going to use blue for Transfiguration. So we're going to have y is equal to, they started with 50 students, and that class size is decreasing at a rate of 2 students per year, so minus 2x. Now we're going to look at our pink line, which is going to be this one right here. So those students started with 30, or that class started with 30. Oh, sorry guys, ignore the dogs. It's probably just the mail. And the class size is increasing, so since it's increasing, we're going to be adding. All right, give me just a second. I'm going to go make her be quiet. All right, sorry about that, guys. So now that we have our system and we've defined our variables, now part B asks, after how many years will the classes be equal in size? So we want to know when those two class sizes are going to be equal to each other. So we're basically going to be doing like what we did in the last one, where we're going to take this chunk and we're going to set it equal to this chunk. So to do that, we're basically taking this and plugging it in for the y. We're getting rid of that y, and now it becomes 50 minus 2x is equal to 30 plus 3x. We're setting those equal to each other. And so now we can solve for x. I'm going to add the 2x over and subtract over the 30. 50 minus 30 gives me 20 is equal to 3x plus 2x gives me 5x. Divide out the 5 and I'll get x is equal to 4. So, but I didn't just ask what's x going to equal. I asked how many years will it take. So we need to say it will take 4 years. All right, so looking at the next problem, part C says, how big will the classes be when they are equal? Okay, so we know after 4 years they'll be equal, but now we want to know how big the classes will be. So we need to take that 4 and we're actually going to plug it in for the x. We know x is equal to 4, so now we just plug that in and we're going to solve or simplify for the y. Okay, you could plug it into either equation. They're both going to give you the same exact answer. I'm going to use the one with the plus sign just because I would rather add than subtract because I like to be positive like that. So we're going to have y is equal to 30 plus 3 times, instead of x, is going to be times 4. So I'll have 30 plus 3 times 4 gives me 12. And 30 plus 12 is going to give me 42. Okay, but I didn't, so we know that y is equal to 42. I didn't just ask what y is equal to, though. I asked how big will the classes be. So we're going to say each class will have 42 students. All right. All right, awesome. Okay, looking at the last one. So number 4 says 2 cab companies charge different rates. So we got Tony's taxis and Connie's cabs. Okay, so if C represents the cost in dollars and M represents the number of minutes, so we didn't have to define our variables, that's nice. Which system of equations could be used to determine the number of minutes for which the companies charge the same amount? Okay, so looking at this, we're really just setting up our equations to represent these little cab companies. Okay, so looking at this, we said that C represents the cost in dollars, so the total cost. Notice all of our equations start with C equals. It's just a matter of figuring out where does the M actually go, okay, because we have 2 options here. Okay, and it says M represents the number of minutes. Well, remember, anytime we see like the per minute, that means it's going to be like 0.5 M. Okay, I'm not going to charge $3 per minute because that's not what it's listed. You start with $3 and then we add the 50 cents per M. Same with this one. This is $60 per minute, or $60. Wow. 60 cents per minute. So that's like 0.6 M. Okay, so we look at which one matches. Well, not this one, because that one has the 3 and the $2 per M. So we don't want that one. We do want the second one, though, because it's 0.5 M and 0.6 M, and that's what we're looking for. All right, so then part B says, choose the solution for the system of equations in part A. So we're really just solving this system that we had. So it's basically what we did in the last ones, okay? We're just going to set these equal to each other. So we're basically taking this one and substituting it in for the C. So we'll have 3.00. You don't have to have the zeros there if you don't want to. They're in the problem, so I'm going to use them. I need to write a little bit smaller, though. 3 plus 0.5 M. And we're going to set that equal to $2 plus 60 cents per minute. And then we're just going to solve. So I'm going to subtract over the 0.5 M. And I'm also going to subtract over the 2. 2 birds with 1 stone. Well, that was an ugly 2, wasn't it? The 3 minus 2 gives me $1 is equal to, those all canceled, 0.6 M minus 0.5 M gives me 0.1 M. So we're going to divide out the 0.1. And that's going to actually give me 10 is equal to M. Okay, so looking at this, we know that M is equal to 10. So we have to look back what our variables represent. And we said M represents the number of minutes. Okay, so we know M is the number of minutes. Okay, so looking at this, we need to figure out where which one of these is talking about 10 minutes. Well, the first one says both companies charge $10 for 8 miles. Well, that's not what we wanted. Both companies charge $10 for 8 minutes. Well, that doesn't tell me what I wanted. Okay. This one says at 10 miles, both companies charge $8. Well, we're talking about minutes here, not miles. So then on number 4, it says at 10 minutes, both companies charge $8, and that's going to be our answer. Okay, and if we were to take this 10 and plug it back into our equations like we did in the other problem, we would get $8 for both of our answers. All right, looking at part C, it says, which company should you call if you only need a short ride for 5 minutes? Okay, so we're going to take that 5 and plug it in for my M's just to see which one's cheaper. Okay, because we want to know which one's going to be cheaper. So for that first equation is for Tony's taxi. So I'll have C is equal to, how much did he charge? $3 plus 0.5 and then per minute, but we know the minutes are 5 now. Okay, so now we just have to simplify. So 0.5 times 5 is going to give me 2.5 plus 3 gives me a total cost of $5.50. Come on, Chromebook. And then we're going to do the second one. That's Connie's cabs. So she had a total cost of $2 plus 0.6 times 5. Well, 0.6 times 5 is going to give me 3 plus 2 is going to give me $5. So which one's cheaper at 5 minutes? Well, that's going to be Connie. So we want to pick Connie's cabs. And that's because it's cheaper. All right, if you have any questions, please make sure you're emailing your algebra teacher so that we can help you out. If not, now you can move on to that Google form that you were given for notes number 4.